passion. Now, let's join our minds to the Almighty. I request Inchara team to render a prayer.
ನಯನ ಮನೋಹರ ರೂಪನೆ ಬೆನಕ ನಾದ ವೇದಮಯ ನಟರಾಜ ತನಯ ನಯನ ಮನೋಹರ ರೂಪನೆ ಬೆನಕ ನಾದ ವೇದಮಯ ನಟರಾಜ ತನಯ ಓಂಕಾರ ಗಣಪ ಪ್ರಿಯನೇ ಗಣನಾಯಕ ನಯನ ಮನೋಹರ ರೂಪನೆ ಬೆನಕ ನಾದ ವೇದಮಯ ನಟರಾಜ ತನಯ ಶಿವನಾತ್ಮಲಿಂಗವ ಧರೆಯಲ್ಲಿ ಸ್ಥಾಪಿಸಿ ಭುವಿಯನು ಕೈಲಾಸ ಮಾಡಿದ ಮಹಾಜ್ಞಾನಿ ಶಿವನಾತ್ಮಲಿಂಗವ ಧರೆಯಲ್ಲಿ ಸ್ಥಾಪಿಸಿ ಭುವಿಯನು ಕೈಲಾಸ ಮಾಡಿದ ಮಹಾಜ್ಞಾನಿ ಮಿತಬೋಧಕನೇ ಅಂಬಾಸುತನೇ ಮಿತಬೋಧಕನೇ ಅಂಬಾಸುತನೇ ಅಮಿತ ಬಲಾಢ್ಯನೇ ಆನಂದ ರೂಪ ನಯನ ಮನೋಹರ ನಾದ ವೇದಮಯ ನಟರಾಜ ತನಯ ಓಂಕಾರ ಗಣ
Thank you. A melodious one. Thank you, team. Indian Space Research Organization. Let us inaugurate the event by an act of nurturing and caring for growth and prosperity. I request the dignitaries on the dais to water the plants. ISRO is the space agency of India. The organization is involved in science, engineering and technology to harvest the benefits of our outer space for India and mankind. Let us see the evolution of this prestigious organization in a video.
India's foray into the space research started in the early 1960s, when the satellite applications were in the experimental stages worldwide. Dr. Vikram Sarabhai, a visionary behind India's space program, had strong conviction that the space technology could be effectively leveraged to tackle the problem of society and the country. The Indian Space Research Organization, ISRO, was founded in August 1969, and it was brought under the organization. The 1980s were the period of experimentation, which saw the demonstration of end-to-end capabilities through Aryabhatta, Bhaskara, Apple experimental satellites, and SLV and ASLV development launch vehicles. These initiatives laid a strong foundation for realization and deployment of operational Indian National Satellite System, INSAT, Indian Remote Sensing Satellite System, IRS, and for development and operationalization of Polar Satellite Launch Vehicle, PSLV. ISRO functions through various centers and units located across the country. ISRO has been making a steady progress in development and deployment of state-of-the-art infrastructure and systems. ISRO successfully conducted the demonstration of autonomous landing of reusable launch vehicle, RLV LEX. Further, ISRO is pursuing its endeavors to develop next generation launch vehicle with higher payload capability while offloading the operational launch vehicles to industry. ISRO and other users. These satellites play a significant role in disaster management in the events of floods, forest fire, earthquake, landslide, tsunami, etc., saving valuable lives and assets. The satellite data have been consolidated, value added, and made available to various users through platforms like Bhuvan, Mosdak, and Vedas. Several government and private users are deriving the benefit out of these portals. NAVIC is the navigation system of India with a constellation of satellites operating from geostationary and geosynchronous orbits. NAVIC provides the position, navigation and timing services for civilian and strategic applications. ISRO is continuously contributing to the capacity building in space infrastructure and human resources in the country through various sponsored R&D programs and outreach activities. ISRO actively collaborates with other space agencies and organizations worldwide. It not only partners with the spacefaring nations, but also works with space-aspiring nations in sharing expertise in space technology and applications. ISRO's contribution with space science missions, namely ASTROSAT, Aditya L1 and ExpoSat, is significant for the space research. Several national and international researchers and institutions have made use of the data from these satellites and brought out publications in renowned international journals. ISRO also undertook space exploration missions of Chandrayaan and Mars orbiter missions to study Moon and Mars. While developing the critical technologies, India has successfully landed its Vikram lander of Chandrayaan-3 closer to the southern polar region of the Moon. It has also deployed Pragyan rover to explore the lunar surface. These missions have not only expanded scientific knowledge but also have garnered international acclaim. Efforts are continued to scale new heights in this journey. Gaganyaan project of ISRO envisages demonstration of human spaceflight capability. The mission is to orbit Indian astronauts at 400 kilometers altitude for 1 to 3 days and bring them back to Earth safely. Various precursor missions are in progress for demonstrating the technology preparedness levels before carrying out the actual human spaceflight mission. These demonstrator missions include integrated airdrop test, pad abort test, and test vehicle flights. Safety and reliability of all systems will be proven in unmanned missions before the manned mission. As announced by Honorable Prime Minister of India,
2035 तक अंतरिक्ष में भारत का अपना स्पेस स्टेशन होगा जो हमें स्पेस के अज्ञात विस्तार को जानने में मदद करेगा.
ISRO is working on realizing an Indian space station, namely Bharatiya Antariksh Station, by 2035 and to land an Indian on Moon by 2040. The journey of Indian space program continues to grow to serve the nation, the citizen and the humanity at large.
Words of welcome fill one's heart with joy. I now request Dr. Nandini Harinath, Deputy Director, ISTRAC ISRO, to welcome the gathering. Professor Sharanappa Ore, Professor Loknath, Professor Naveen Kumar, M.R. Raghavendra, our Associate Director ISTRAC, Jaswinder Singh Koval, Shiv Prasad, Dr. Anand Kumar, Registrar Evaluation. ಇಲ್ಲಿ ನೆರೆದಿರುವ ಎಲ್ಲ ಗಣ್ಯರಿಗೆ, ಮೈ ಇಸ್ರೋ ಕೊಲೀಗ್ಸ್, ಪ್ರೀತಿಯ ಮಕ್ಕಳಿಗೆ, ಟೀಚರ್ಸ್ ಎಲ್ಲರಿಗೂ ನನ್ನ ನಮಸ್ಕಾರ. ನಭಮಂಡಲದ ಬಗ್ಗೆ ನೋಡಿದಾಗ ಅದು ಒಂದು ಅತಿ ಚಾಲೆಂಜಿಂಗ್ ಕ್ಷೇತ್ರ ಅಂತ ಗುರುತಿಸಿಕೊಳ್ಳುತ್ತೇವೆ. ಯಾವುದೇ ಮಗು ಆಗಿರ್ಬೋದು, ವಿಜ್ಞಾನಿ ಆಗಿರ್ಬೋದು, ಸೀಸನ್ ಸೈಂಟಿಸ್ಟ್ ಅಂತೀವಲ್ಲ, ಎಲ್ಲರನ್ನೂ ಬೆರಗುಗೊಳಿಸುವ ವಿಚಾರ ಬಾಹ್ಯಾಕಾಶ. ಟುಡೇ ಇಸ್ ಜಸ್ಟ್ ನಾಟ್ ಅನದರ್ ಡೇ. Today is in the honor of an event that took every Indian's imagination on a flight to the moon. Our curiosity to the stars. I'm thrilled to see this huge audience, and all of you, I'm sure, are waiting in anticipation of today's program. That video that you saw was just a starter. Today we have curated for you a very exciting program, a lot of events and talks from our renowned guests today. And I'm sure all these talks are going to inspire you. But first of all, let me do my duty as a chairperson of this organizing committee to welcome our esteemed guests. First, I request Kumar Anand from ISRO to come onto the stage to welcome Shri Professor Sharanappa, Vice Chancellor, KSOU. I now request Shri Suresh from LPSC to welcome Vice Chancellor, University of Mysore, Professor N.K. Lokanath. I now request Narendra from LPSC to welcome Registrar KSU, Professor Naveen Kumar. I now request Shri Kamran to welcome our chief guest, M.R. Raghavendra, Associate Director, ISTRAC. I now request a volunteer from KSOU team to welcome Chairperson NSPD, our main committee, Shri Jaswinder Singh Koral. I now request another KSOU member to welcome Shri Anand Kumar, Registrar Evaluation, KSOU. I welcome Shri Shiv Prasad from LPSC. I request another KSU member to welcome Shri Shiv Prasad.
I request another KSU member to welcome Shri Naveen Kumar, Registrar, KSU. Okay, not but not the least, I welcome you all students for this event. Thank you so much for coming here. I'm sure you'll have a very good time. You'll learn lots of things, and I'm sure that all of you are going to take back a lot of things from this event, not just fun times, but a lot of things that you're going to use, a lot of life lessons that you'll probably use in your life. I also welcome Mysore Science Foundation members. Can you please stand up? Yeah, thank you for coming. Yeah, welcome to this function. I welcome Gravity Science Foundation members. Thank you so much for coming. And I welcome Ganita Kunita organization members. If they're here, kindly stand up. And I welcome Mysore Quiz Group to this function. Okay, they're somewhere there, yeah. And I welcome you all once again. Thank you so much for coming, and I hope you'll have a great time.
I would also like to invite our statutory officers, Professor Ramnatham Naidu sir, Dean Academic, KSOU, Dr. Chandragowda sir, Dean Study Center, KSOU, Professor Niranjan Raj sir, Finance Officer, KSOU. And I would also like to welcome Srinath sir from ISRO, who has been supporting me from day one. Thank you sir. Welcome sir.
So that's a very grand welcome from both the teams. We welcome Nandini Madam for this event with a flower bouquet. I now request Mr. Jaswinder Singh Koral, Chairperson of NSPD Committee, to enlighten us the significance of National Space Day. Sir.
Good morning, everyone. Professor M.K. Loknath, Vice Chancellor, University of Mysore, Professor Sharnappa Halse, Vice Chancellor, Kesau, distinguished guests on the dais, including my good friend Raghavendra, distinguished guests from all over Mysore, and of course my dear students. Today we are all gathered here to celebrate the National Space Day 2025, and it is my pleasure to welcome you all here for this event once again. So as you all will be aware that on 2023, August 23, the Chandrayaan 3 spacecraft touched down on close to the south pole of the moon, about 70 degrees south, and this was the first time that any spacecraft had done so. Usually they sort of land close to the equator of the moon. And if you go by the statistics also, if you will recall, first there was one Russian attempt to land on the moon just close to Chandrayaan 3, and that failed. So if you see the statistics, it's about success rate is close to 30 or 40% only, and not more than that. In view of this statistics, it is very, very significant that India has achieved this great milestone. So after the successful landing of Chandrayaan 3 Vikram lander on the moon, and that's what has been now named as Shiv Shakti Point, the rover Pragyan rover rolled out, and it had traversed some of the distance on the moon surface and done some science experiments. It was alive for one lunar day, that is 14 Earth days. And then there's a long lunar night of 14 days, which it of course could not survive. So this is the background for why we are here, because after the successful landing, the government has declared 23rd August as the National Space Day, to be celebrated all over India, and not just by ISRO, but by the entire community of scientists, academics, students, and even the startups and space companies. So why are we talking about space today? As you all know, that space for so many decades has been an integral part of our lives, whether it's communications, navigation, or remote sensing, telemedicine, teleeducation. All of these facilities have touched each and every one of our lives. So we are already familiar with the many applications which space provides. It is an integral part of the infrastructure of modern living. There is no doubt about that. There's no two ways about it. But increasingly, as you are aware, space is not only about application. Space is also a very vital national asset. It's a sovereign asset. And there has been a race recently to visit the moon and other planetary bodies like Mars, the asteroids. People are even talking about mining on the moon and on the asteroids because there are a lot of economic benefits which are possible to be reaped due to these things. All of these call for us missions which are, in terms of the complexity and challenges of Chandrayaan-3, orders of magnitude higher. So you will understand that if we have to be a part of this and not get left behind, then it is students like you, the youth of tomorrow, who will be leading that charge. And it is our duty to bring you these exciting challenges, to make you aware of them so that you can be a part of this exciting journey. Even if you don't work directly in the space industry, you might be working in the field of electronics, material science, structures, thermal engineering, so many other areas which will directly or indirectly contribute to the space sector. So there is a lot of work, lot of opportunities, and lots to do. And there will be challenges like landing a human, an Indian on the moon. That has been one of the government's objectives by the year 2040. Maybe a manned mission to Mars following that, and also maybe missions to asteroids where we can take up economic activity like mining and so on and so forth. So all of these call for very advanced technologies, rockets, engines, spacecraft, autonomy, today's buzzwords of AI, ML, and autonomous systems, robotics. All of this will be present in abundance in any of these missions which will follow. We want to make you aware of all this. We want you to be a part of it, and that is the significance of National Space Day. It is not just to celebrate our past achievements and to bask in the glory of those achievements. Yes, we are happy about that, but we look forward to the future and the challenges, and we want you youngsters, the future, the bright future of our nation, to be a part of that. Thank you very much. I hope you have a good day today. You feel free to interact with all of us, whatever questions you have, and we will try to answer to the best of our capabilities. Thank you all. Jai Hind.
Thank you, sir, for giving us that valuable insight. As a token of appreciation from both ISRO and KSOU team, I request Raghavendra sir to present the memento. Dear all, I am happy to announce that various eminent scientists from ISRAC team, Dr. Subramanya Ganesh and Dr. Hemlata Gnaneshwar are present here, along with scientists from our LPSC team. Students, kindly interact with them during the lunch break. I now call upon Mr. Professor N.K. Loknath, Vice Chancellor, University of Mysore, to address the gathering.
ಎಲ್ಲರಿಗೂ ಬೆಳಗಿನ ಶುಭೋದಯಗಳು. Dignitaries on the dais, dignitaries after dais, and my dear students. Today, it gives me immense pleasure to be here. We are going to celebrate the National Space Day of 2025 organized by the KSOU and the Indian Space Research Organization. I hope this event is mainly concentrated to the students. Hope all students will need to interact with the scientists of ISRO, and also you should know how space science helping the mankind and the society. So the theme was very interesting. So that means it's from Aryabhata to Gaganyaan, an ancient wisdom to infinite possibilities. And this is a very good opportunity for all the students to know the progress of space science of India. And I am very sure that most of the students are very much interested in space science. But in order to do the space science, we need to go a long way. That means, we have just seen the video. It was started very long back of 1960s. Today, we are the leading country in doing space science research and space science activities in the world. So you should understand that even in the olden years, like for example Aryabhata, Bhaskara, Brahmagupta, which you can say that 1500 years ago, there is a mathematical calculation from the Indian science that they have calculated all the satellites and everything on track. So that means, so India is not just started the science, it has been started very, very long back. Now the question is, so as you see that every day the technology changes. Every day our need is changing. So we need to look for other things. So for example, say space mission or Mars mission, or you can go to the International Space Station. So we need to understand how really the nature changes day by day. We need to understand that we need lot of scientists from all the corners. Just I am discussing with the assistant director of this ISRO. Nowadays, only, and in the olden days, only science graduates only can go to the space, ISRO. Now it is not the case. We need all the type of students. So that means all the type of stakeholders to enhance our capability to understand the space science. I am really very happy that ISRO has taken into the Mysore, and it's a very good opportunity for all the students to see the models. That means whole machine, that means their missions has come to the Mysore, particularly to the KSOU. So it's a great opportunity for all the students to see that and also understood. So, and also you should try to understand how this space missions has been taken up and what are the preconditions for this. So that you need to understand. And moreover, the space exploration itself is a very interesting phenomenon. So therefore, you all students have taken a break from the class. I am seeing all students look very serious. Don't be serious. Be smile on your face. Be optimistic. You want to know, right? Here the program is coming to make awareness about space science. So I am seeing from the there that most of the students are looking very serious. Don't be serious. So here is the one where we get some knowledge, right? So am I always telling, education is very important. Why do you need education? Education is to gain knowledge. So everybody study education to knowledge. That knowledge should transform to wisdom. Then only it will be. Therefore, this is a very good opportunity for all students how to increase your or to enhance your knowledge in the particular in the space science. So I really appreciate the efforts taken by the KSOU team as well as the ISRO. So coming all the way to Mysore so that our kids definitely will have an impact on space science in future. So all the best and thank you once again. Good luck.
Thank you, sir, for the wonderful talk. I request Dr. Niranjan to present a memento to Professor N.K. Loknath, sir. And students, we are fortunate to have Srimati Nagalakshmi, Project Director of ISRO, and Selva Pillai Iyengar, along with faculty members of KSOU, kindly use this opportunity to enhance your knowledge. And now, I call upon Professor Naveen Kumar, Registrar, to deliver the talk.
ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. Good morning all. The dignitaries presented here in the dais. Our Vice Chancellor Sharanappa Halse and our Vice Chancellor of my University Loknath sir and Nandini Remat, and then Associate Director Raghavendra sir and all scientists from the ISRO. Today we are gathered here to celebrate National Space Day 2025, and this eve we have organized Aryabhata to Gaganyaan, Asian wisdom to infinite possibilities. So I think all the students will get benefited from this program. So I am happy to inform that I did my project in ISRO under Vinod Chappalkatti more than 8 months on telemetry and telecommanding. And also I am happy to remember our NCF Director Rangarajan and GS Raju and Sethuraman, Guru Prasad, who taught us the different technologies in the space while I am studying the MSc Electronics in Hassan. So this is one of the happiest moment to remember them. So on this eve, I would like to remember the father of space, Indian space technology, Vikram Sarabhai, and the missile man, I think students know Dr. APJ Abdul Kalam. He invented a ballistic missile and aerospace vehicle. So he made the advancement in the space technology. So that because of that we are using much advanced 5G, 3G, 4G, what we are talking about because of this space technology. And just I wanted to give a glimpse, say that earlier used to send information in the form of ಹಿಂದಿನ ಕಾಲದಲ್ಲಿ ಏನು ಮಾಡ್ತಾಯಿದ್ರು, ಒಂದು ಇನ್ಫಾರ್ಮೇಷನ್ ಕಳಿಸ್ಬೇಕು ರಾಜರ ಕಾಲದಲ್ಲಿ ಅಂತ, ಜಸ್ಟ್ ಲೈಕ್ ಒಂದು ಬೆಟ್ಟದ ಮೇಲೆ ಒಂದು ಹೊಗೆನ ಹಚ್ಚಿಬಿಟ್ಟು ಒಂದು ಡಿಫ್ರೆಂಟ್ ಕಲರ್ಸ್ ಆ್ಯಡ್ ಮಾಡಿ ದೇ ಸೇಯಿಂಗ್ ದಟ್ ದಿಸ್ ಇಸ್ ದ ಒನ್ ಆಫ್ ದ ಇನ್ಫಾರ್ಮೇಷನ್. ಸೊ ಪೀಪಲ್ ಫ್ರಮ್ ದ ಫಾರ್ ಡಿಸ್ಟೆನ್ಸ್ ನೋಡಿದ ಮೇಲೆ ಅವ್ರು ಏನು ಹೇಳ್ತಾ ಇದ್ರು, ದಿಸ್ ಇಸ್ ದ ಇನ್ಫಾರ್ಮೇಷನ್. ದೆನ್ ಸೆಂಡ್ ದ ಪಿಜನ್ ಬೈ ಟೇಯಿಂಗ್ ದ ವಿಚ್ ಒನ್ ಟೈಡ್ ಮಾಡಿ ಅದಕ್ಕೆ ಒಂದು ಕಾಗದ ಕಟ್ಟಿ ಒಂದು ಜಾಗದಿಂದ ಒಂದು ಜಾಗಕ್ಕೆ ಕಳಿಸ್ತಾ ಇದ್ರು. Like that advancement happened in the technology. So after then telephone bantu, then mobile technology. Because of this mobile advancement, what the data we are receiving every day, lack of data we are receiving because of that space technology. So then this is only sanna ಒಂದು talk ಮುಗಿಸ್ತೇವೆ, because keynote speaker address ಮಾಡ್ತಾರೆ about what is the advancement of space technology ಅನ್ನೋಗೆ. ಇದಕ್ಕೆ ನನಗೆ ಆಪರ್ಚುನಿಟಿ ಕೊಟ್ಟ ನಮ್ಮೆಲ್ಲ ಇಸ್ರೋ ಸೈಂಟಿಸ್ಟ್ ಮತ್ತು ಆಫೀಸ್ ಬೇರರ್ಸ್ ಮತ್ತು ನಮ್ಮ ಯೂನಿವರ್ಸಿಟಿಯ ಎಲ್ಲ ನನ್ನ ಇವರಿಗೆ ನಾನು ವಂದಿಸಿ, ಮತ್ತು ನಾನು ಎಸ್ಪೆಷಲಿ ಥ್ಯಾಂಕ್ಸ್ ಟು ನಿರಂಜನ್, ಬಿಕಾಸ್ he did lot of exercise for this short duration. So I made the program wonderfully, and also I thank all office bearer of my university. Thank you one and all.
Thank you, sir, for enlightening the students. I request Dr. Niranjan to present a memento. I now invite Professor Sharanappa Halse, Vice Chancellor of KSU, for presidential talk.
Namaskara. Good morning to all. Respected Chief Guest of the Additional Director, Dr. N.R. Raghavendra, Chairman of MSD Main Committee, Jaswant Singh Korwal, Honorable Vice Chancellor of University of Mysore, Professor Loknath M.K., Registrar of this University, Professor Naveen Kumar S.K., Deputy Director of ISRO, Dr. Nandini Additional General Manager, Professor Dr. C. Prasad, dignitaries, scientists from the ISRO, my dear colleagues, my dear students, friends, invitees, many persons. As you know very well about that today we are celebrating the National Space Day. It is very, very important event for all our students. You know very well about that. Day to day already our Professor Loknath, Vice Chancellor of Mysore University, told that is a lot of changes in the technology. That there is a sea change. Already you know there was a small scale integration was there, and medium scale integration, large scale integration, very large scale integration. Now you see the lot of change in the technology also. That is why we must do what are the activity, development and going on in the space. That is why our children, they have to take more interest for the space science and invention. I saw the actually Vikram Sarabhai Space Center in Tumba, that is in Trivandrum. You see there is a lot of research is going on. And I think almost all students, young generation, they know that is how the rocket is launching. Almost all that SSLC students, they are knowing that is all physical parameters are converted in the form of the mathematical equations. Those equations are solved in the form of a integration. I think you know very well that is all the SSLC students, they are having the knowledge about that how the rockets are launching in the space. That is why all young generations, they have to take more interest in the space to lead a good life. Already all the dignitaries, they know that is how the days are changing. Now the small earlier our Naveen Kumar told that to send the message from one place to communication from one place to another place, they used a letter, that is a post office, they very easy. Now the space science, you can send your emails anywhere throughout the world. Almost 193 countries are there in the world, and you can send your message from sitting here. That is actually it is a space research. That is ISRO's, they are helping for that. That is why you take more interest, and our Department of Physics and the ISRO's combined, they have taken more interest to celebrate the space day. That is why all our students are here, and they have to take the benefit of it. And I congratulate all my fraternities for arranging this event successfully, and thank you one and all.
Thank you, sir, for your words of wisdom. As a token of appreciation, I request Professor Ravi Kumar to present a memento. Now, let's move on to the lecture series. I request the dignitaries to occupy the front row, please. Dr. M.R. Raghavendra is currently Associate Director ISTRAC and holds additional charge as Deputy Director for Ground Station Network Area GSNA. He joined URI Satellite Center, that's URSC, in Feb 1992. He was working in spacecraft integration and checkout area of URSC. He specializes in the field of RF and microwave communication and digital signal processing techniques. Among many of his responsibilities and holding many important positions, he was also Deputy Project Director for remote sensing satellites, taking care of spacecraft integration and checkout activities. He was very closely associated in the integration and testing of both LEO and GEO missions of ISRO. He has pioneered design and development of high bitrate receivers in the 1990s and early 2000s. Later, he spearheaded the indigenous development of SDR-based PTC processor. Before being transferred to ISTRAC in December 2020 as Deputy Director, he was working as Group Head Spacecraft Checkout Group at URSC. In the present additional capacity as Deputy Director for Ground Station Network Area, he is in charge of all ISTRAC TTC ground stations, including 32-meter and 18-meter deep space antennas, which are main ones for communicating with Chandrayaan 1, 2, Chandrayaan 3, Mars Orbiter Mission and Lander Module. He is a Fellow of Institution of Engineers, Fellow of IET, and is a Chartered Engineer. He is recipient of ASI Merit Award. He has many technical publications to his credit. May I now invite Sri M.R. Raghavendra, Honorable Chief Guest, to deliver the talk on Aryabhatta to Gaganyaan, Ancient History to Infinite Possibilities.
Okay, then I'll stand here and give a presentation. Good morning to you all. Greetings on this occasion of celebration of National Space Day. Respected dignitaries of the dais and all my dear friends, and all the children, students from all over Mysore who have assembled here. So briefly, I will take you through the journey of space science, which has astronomy and space science, which has evolved somewhere in the ancient times. Next slide, please. See, as such, India, as we all know, have a very rich heritage in astronomy and space science. We have come a long way, starting from the findings, the studies carried out by Aryabhatta, to you are able to hear me? Yeah. Yeah, this will be better. So, starting from, Aryabhatta, which was somewhere around 1,500 years ago, he did a fantastic studies about mathematics and astronomy. The next slide, please. You see, there are many contributors to the ancient science and mathematics that has evolved over many years and centuries. So taking for example Aryabhatta in the from the year 476 to 550 Common Era, he did fantastic job. In fact, he has written this book Aryabhatiyam, which actually covers various aspects of mathematics, science and astronomy. If you see his contribution has been exemplary. In fact, all the ancient astronomers were very good mathematicians. The very source of astronomy is from the fundamentals of mathematics. So let us say, for example, the Aryabhatta, when he started this studies on astronomy, he made extremely good contribution in geometry, especially the spherical geometry, trigonometry, and he actually gave the exact calculation for pi and even the Earth's circumference as well. So you can just imagine whatever the formulas that we have used right now we use to calculate the circumference of Earth. He had actually done it very accurately in those days, of course using the calculation for pi. Following him we have Varhamira, then Brahmagupta and Bhaskara, who have done exemplary work, taken forward the work that he has actually done. In fact, Brahmagupta, as you all know, he gave zero to this world. You know, it is with this contribution, which is one of the best contributions what India can give to this world. So likewise, we have almost, you can see the map there, from all over India, we have astronomers ancient astronomers who have contributed immensely to the field of astronomy and space science. Next slide, please. Now, if you see, I'll just give an example of what, Aryabhattiyam. There are many such sutras, almost around 14 to 50. There's a big list of documentation that is available from the ancient history. Now, if you take just the Aryabhattiyam, actually Aryabhattiyam has four chapters in that. The first one is Gitika, then Ganita, Kalakriya and Gola. If you see in each of these, they have actually dealt about the number of revolutions the planets makes in a yuga, or even the position of a planet. Like what we call as apogee, we have the apihelia and its diameters, inclination. See, they basically dealt everything about the ecliptic plane, which we are nowadays studying. And even if you take, for example, the mathematical equations, the quadratic equations, the linear equations, and all these were actually embedded in all those the slokas that were already there in this Aryabhattiyam. Go to the next slide, please. If you say, for example, see some of the slokas which are here, which actually talks about the ecliptic plane, and we can see that if you take, for example, the first stanza, it talks about the ecliptic plane, how ecliptic plane is identified, from Aries to end of Virgo will be on the northward tilt, and coming to the Libra and to Pisces in the southward tilt. This is the kind of observations that was made and the deductions that were made, and which is quite accurate even to this day. So it is given, this only an example. Likewise, there are many shlokas where lot of mathematics and lot of space science is actually embedded. This is one of the examples. Here, this is one thing that I would like to emphasize here. See, we had lot of work that is done by our ancient astronomers and scientists. But the documentation is, it's only limited to some of the shlokas and not accessible to everybody, like what Westerners did. So this is where we lack. We have to improve the documentation. I think all the students here should take at least one essay that you should improve your documentation. Whatever you do, whatever you study, whatever you are seeing around you, you can go on publishing. This is what is happening in most of the Western countries, where at your age, people are encouraged to start documenting. So this documentation is very, very important. Go to the next slide, please. So these are some of the examples which I would like to give, where they have told so much about our astronomy in these shlokas. Unfortunately, these things are not very easily available to everybody to understand and take it forward. So what the Westerners or other countries did this, they made these very easily available to people, so that it could be taken forward. That is how we get very good documentation available for the other countries, whereas whatever we have done within India, we are not having very good documentation. The next slide, please. Now coming to taking forward from the astronomy, see, after we have Galileo who had discovered the telescope, then we established the first observatory in Madras in the year 1792. And it is here the people started studying about solar eclipse. The next slide, please. See here, there's this one scientist, the Pogson. Actually, here I would like to mention, we had one scientist, Raghunathachari, who was actually working on the solar eclipse time. So he is the one who brought in Pogson to India, and he discovered from the same Madras observatory, he discovered helium during one of the solar eclipses in 1868. So this is the kind of contribution what India has made to this world. Next slide, please. Now, taking forward in the field of astronomy, we have established in India a number of observatories. So starting, it's also spread across India, and we have almost around 6 to 7 observatories which are popular and doing lot of space studies. A lot of space science is being done in these observatories. Go to the next slide, please. For example, we have, this basically, when Galileo discovered telescope, it was basically a refractive telescope. Because after Newton, Sir Isaac Newton, who brought in this reflective telescope. And these reflective telescopes have become very, very popular, basically because it can be easily built and used. So these are the things that actually go into a telescope. For children, you must have studied in your textbook. These are the kinds of huge mirrors. What we see in our physics textbooks right now, we see only a mirror, but what goes into making a mirror, the kind of technology that goes into making a mirror is huge. Next slide, please. Now coming to this is one of the observatory, which is Giravali West Observatory, which is a 2-meter optical telescope. The next one. I'm just skipping through some of the telescopes that are, so that you get an idea about how a telescope would actually look like, how different types of telescopes are actually made. Next, please. So this is one of the telescopes that are that is situated in Leh Ladakh. This is actually a 2-meter telescope, and this is a high altitude gamma ray detector. So these detectors are used to study the gamma rays. This is using the Chernikov phenomena, where when the gamma rays hit the atmosphere, the air particles in the atmosphere, they give a flash that's called as Chernikov phenomena. They capture those phenomena to detect the gamma rays. Next slide, please. This is another telescope which is there in the Vainubapur Observatory, which is very well known, which is there in South India in Tamil Nadu. This is again a 2.3. A number of telescopes are the 2.3 meters, one of the largest that is there in Vainubapur. We have many other telescopes. This is another telescope that is there on Mount Abu, which is established by Physical Research Laboratory. Next slide. And this is another telescope that is there in Nainital. This also does a lot of solar studies is done here. Next one. There is also Udaipur Solar Observatory, where we study exclusively the solar phenomena from these telescopes. Next one. Then in Ooty we have the radio. See, apart from those optical telescopes, we have the signals that are coming from from celestial bodies. So we capture those signals. Those signals are captured. That is going to give a lot of information about the nature, the composition of the celestial body, and this is very, very useful system. Next. Now coming to another telescope that is also situated in Gauribidnur in Karnataka. Next. This is the giant meter wave telescope which is there in Pune, which is a huge array of telescopes. Each telescope is each antenna is around 45 meter. 45 meter is almost around 100 feet of dimension, more than 100 feet dimension antennas. With around 30 antennas are situated to study the our cosmos. And this is another in Kodaikanal. Next. Yeah, now coming to coming to the space studies, formation of ISRO, as you have seen today in many of in the video, the formation of INCOSPAR, then the first sounding rocket that was launched in 1963, and ISRO was formed in 1969. See, the basic vision was to enhance the development or cater to the needs of society through space technology. That was the basic purpose of starting the space science, space research in India. The very vision, what we will see in the next slide, was to take care of the societal needs. That was the fundamental vision of our founder father, Dr. Vikram Sarabhai. So his idea was that we should be none to anybody. We can be second to none in this world of application-oriented deliveries for the society. Next slide. So this is one interesting place where we actually started the first sounding rocket. This is the Tumba, which you would have seen in the videos. Why Tumba? Why Tumba was chosen for launching the sounding rockets? Basically because the magnetic equator goes over Tumba, and because of the magnetic equator being there, there's a lot of phenomena that is happening. The electrojet phenomena that is happening in the upper atmosphere, and the United Nations actually wanted somebody to take up this studies on this phenomena. The normal sounding balloons, earlier balloons were left to the atmosphere to study the atmospheric conditions, but this was even beyond that. So they gave a proposal, anybody would come forward to take up the studies, and that had to be done only by a sounding rocket. So then India came forward to say that we gave this land for them to carry out this first sounding rocket. That was a US-made rocket. Following which, after 4 years, that was in 1963, following which we started doing our own sounding rockets. We have Rohini rockets. Now we have RH-560, huge rockets that are there for doing the sounding. Sounding basically is to find out the atmospheric conditions. Could be the wind direction, wind velocity, the activities that are going on. So next slide, please. And then we had the first satellite, Aryabhatta, which was launched in April 1975 by a Soviet Union rocket that's called as Cosmos 3M. From a Soviet soil it was launched, and it was basically meant for X-ray astronomy. That was our first successful satellite, which marked the beginning of our entry into space technology. Next slide, please. So India, as in Indian space, has actually achieved many milestones, starting from the sounding rockets, which I mentioned in 1963, followed by the indigenous development of launch vehicles. Now today we have a series of lectures on the launch vehicles also, and we have a series of lectures on different, on the Chandrayaan, where the speakers are going to touch upon the satellite technologies also. And here we have the remote sensing satellites and the Indian communication satellites, followed by the astronomical experiments, satellites meant for carrying out astronomical experiments. And we have the deep space missions like Chandrayaan, Mangalyaan, and the Aditya L1, etc. Following which, I'll be discussing a little more on the Indian space policy, which has come up in 2023, which is going to throw open the avenue for all the private users to start venturing into the space technology. Next slide, please. Now these are the different ISRO centers that are spread across the country. I'm not going to go too deep into it. Next slide, please. And these are some of the major achievements that we have got till now. Especially in the launch vehicles, you can see how we have progressed from SLV to PSLV, GSLV, and now the GSLV Mark III, which is presently the heaviest launch vehicle that we have. Following which we have in future we are going to have NGLV, and I think that's also going to be touched upon by the speakers. I'm just going to give you this is just going to be setting a the mood for the following lectures that are going to go in little more detail in all these. And we have a number of satellites. Next slide, please. And this is one of the recent reusable launch vehicle experiment that was carried out. And as you see, you must have seen in the video as well, this was carried out in Chitradurga in Karnataka, where we had a winged body. It is like our space shuttle. You must have all seen the space shuttle. So it is that kind of a space shuttle which is going to be used as a reusable launch vehicle, where it was dropped. You can see, this is one of the first experiments that were done to see how it can get guided on its own and land on the runway. If you can just give a comparison, this lands at the speed of around 375 kilometers per hour, unmanned. It is an unmanned landing at a speed of 375 kilometers. This is something fantastic and really phenomenal achievement by ISRO in winged body launch vehicles. Next slide, please. And this is, of course, the Gaganyaan, the first TVD-1, the first experimental developmental vehicle which was meant for testing the crew escape system. So this is one, can you just go back? This is one, you can see the left side. This is the launch vehicle where in most of our launch vehicles we have the first stage is the solid, and this is where we have the first stage is the liquid stage. And here you can see behind this there's a recovery module which was recovered, the top module where the crews are going to be there. Behind the people who are standing there, you can see that module there. Next slide, please. And this is how our space transportation system has evolved, which is also going to be dealt in the coming lectures in more detail, where we have started from even the SSLVs, and then we are going up to 2030 where we are going to have very heavy launch vehicles. And there are a few new technologies. Scramjet. See, Scramjet also is one of the fantastic technologies where is an air breathing technology where we are going to take the oxygen from the air. Instead of carrying oxygen here, we take oxygen there and then use it as a oxidizer for igniting the fuel for generating the required thrust. And this will be done at a hypersonic speed. Really, it is 5 times the speed of sound. At that level, at that speed, this activity will be taken up. Next slide. And these are the host of Indian satellites that we have actually launched, starting from Apu. That was the first communication satellite that we did. Starting from Apple, we have a number of satellites in different categories. Say especially the small satellites, you can say some Earth observation satellite, that what we call it as IRS. Then we have a communication satellites like INSAT or GeoSats. Then of course we have the NAVIC satellites, which was also seen in the video here for navigation purposes. And we have the interplanetary missions, Chandrayaan-1, then Mangalyaan, then we have Aditya L1. So these are some of the new interplanetary missions that we have taken up in the recent past. Next slide, please. This only shows how we are evolved, from the first satellites, first launch vehicles to the more complex systems. And these are the different orbits that we right now you can encounter in most of our satellites, starting from the low Earth orbit, the medium Earth orbit, and geostationary orbit. These are some of the things that you would have probably studied in your textbook. Then there are some variants here. And there are some orbits where we use the gravitational force of a particular celestial body, a planet, or any other body, to propel ourselves to longer distances. That is called as, gravity-aided transitions, where when the satellite appears very close to any other planet, it is pulled by the gravitational force of the planet, and there its speed increases. So using that speed, you can go a farther distance without expending much of the fuel. This is called as the gravity assist trajectories. Next slide, please. And this is how the Chandrayaan trajectory, I'm not going to go deep because Dr. Nandini Harinath will be covering it in little more detail. And this is how, the landing trajectories really happen. Next slide, please. And this is Aditya L1 mission where we had sent the moon to the Lagrangian point. So Lagrangian point, I think you must have studied. Some of you must have studied, right? Lagrangian point. Yeah, so we have gone to this L1 Lagrangian point. There are 5 Lagrangian points where the body is moving at a constant distance from all the other celestial bodies. Like example, there are 2 bodies, sun and moon, sun and earth. And there are 5 Lagrangian points that can be there where their position is fixed relative to each of these, both the bodies. And we have the L1, that is between sun and earth. So we have a satellite there, which is going to be useful for studying the coronagraph. It has a coronagraph which will see the outer atmosphere of the sun. And it has a unique trajectory here. You can see how the satellite has moved from earth to the Lagrangian point. Next slide. And this is how we have evolved in the camera technology. See, satellites are meant for having cameras for doing some particular operation, like it could be imaging, or it could be for it could be optical imaging or infrared imaging or whatever imaging where we get to know about the crop, forest, and even for cartography. So this is how we have evolved from a very low resolution to 1 kilometer resolution to we have now achieved sub-meter resolution. So that's the kind of evolution that has happened within Indian space program, which has taken us to a stage where we are no less than what US or any other country is doing with respect to the satellite technology. Next slide. And these are some of the solar astronomy payloads that are there and which we have flown on many missions, which have given extremely good information about our astronomy. And in fact, we have Indian Space Science Data Center in ISRO, where we have the huge collection of science data from all these missions, which are going to be useful in understanding our solar system in general and universe, a solar system in particular and universe in general. Next slide. And these are some of the applications which I mentioned, which are going to be very useful, why the satellites are required and how they are going to benefit the society. There are some of the points that are given here. Next slide, please. Now, this slide, it shows the distances from Earth to Mars. Here I would like to draw your attention to one thing. See, when we started our sounding rockets, we were had to communicate only to an extent of around 10 to 12 kilometers. But now we have to communicate with our satellites, which are around 250 up to 400 million kilometers. So that's the kind of communication link that we have to establish. See, as the Vice Chancellor was also mentioning, we had an ancient time of how communication started those days. Now communication has also advanced so much that we are able to communicate very well. But all these communications are around Earth, very close to Earth. But if we have to communicate with some spacecraft or some other object which is 400, 500 million kilometers away, we need a huge ground infrastructure, how to communicate. Maybe in following slides I will highlight how we can communicate with those distances. Next slide, please. And these are some of the, till now we have only talked about the satellite, but now we have to communicate with these satellites also. How the ground system has evolved from earlier to now. How ground power off. Yeah. So how the ground, and to communicate with the launch vehicle or the satellite, we need to have ground stations at different locations. Next slide, please. This is our campus in Bailalu in Istrak, where we have the deep space antenna. So any of you who are interested can come over, have a look at these antennas also. Next slide. And these are some of the different types of antennas that we use for communicating with the satellites. Next slide. And this is a network of stations that are there and how they are all networked. Next slide, please. And this is the trajectory how a launch vehicle. Maybe most of you would have seen the launch of many of our launch vehicles. You can see the trajectory on the screen, on your TV screen. You will see the trajectory. But now throughout, when the trajectory is going, we need to communicate. So we have different ground stations at relevant places, so that they can be communicated all the time. Next slide. And this is our spacecraft operations at a glimpse. This is, you can see at the center, this is how our spacecraft operations area would look like. You can see all the experts sitting in the center and controlling the spacecraft. And there are different phases in which goes into the spacecraft operations. Next slide. And this is only to give a glimpse, so I'll just go through this fast. This is how you have around 26 low Earth orbit satellites revolving in different orbits. You can see on the right side corner, you can see different satellites moving in different orbits, and this is how it is going to be. So all these 26 satellites have to be communicated as they move around these different orbits. Next slide. And this we have the satellite navigation. I'm just going to give just an introduction about the satellite navigation. Now we have all heard about GPS, right? GPS in our mobile phones. And now this NAVIC is a navigation for Indian Indian constellation. This is meant for navigation for Indian region. This is how it is. But in future we are going to expand it to global as well. Now to control these satellites, these navigation satellites, the timing. Next slide, please. These our NAVIC satellites gives an accuracy, a location accuracy of around 10 meters. That's its specification. We get better than that. And to get that accuracy, we need a very accurate time information. So the distance is derived using precise timing information. If the timing information is very good, the distance, the accuracy that you get will be very good. So we have a center in Bangalore where we give the ground segment, which is going to give a very accurate time information to enable us to get fine resolutions in distances, position expected. Next slide, please. Now this is our computer network, which is used for controlling these satellites. Next slide. And since very sensitive information comes in these satellites, we have to have very good cyber security system in place so that it is not misused. Next slide. And this is how we have, along with the terrestrial communication for the network, we have the satellite communication, which is using our own GeoSat satellites to communicate with these satellites. Next slide, please. And this is where I was mentioning about the science data that we are acquiring are stored here in this center, which is having a storage capacity of 3 petabyte. That's the kind of capacity that is there. And with this information is given to everybody. In fact, everybody, all of you can in fact log into this website and get whatever information you want about our astronomical satellite data that is coming there. Next slide. Now, till now we had an vision, what Dr. Vikram Sarabhai had envisaged. Now we have a vision that is slightly different, where we are going to involve even the private participation in this whole area. Next slide. And this is the future research programs that we have, which we have envisaged for ISRO. We have more advanced remote sensing satellites that are going to come up with high throughput communication satellites. Then we have the MEO NAVIC constellation. Then we have the whole of the Gaganyaan series that is going to come up. And then the Chandrayaan series. Then we have the Bharatiya Antariksh Station, which is going to be our own ISS. Like ISS, we have our own space station. Then we will have our Venus orbiter mission, and where we are going to go up to Venus and study the atmosphere of Venus. And we have the next generation launch vehicles. If we have to go with the Bharati Antariksh Station, the launching capability is not enough right now, whatever we have. We have to go to a next level where we can carry more heavy mass into the low Earth orbit. Then later we have the crewed moon mission where we are going to land on moon and colonize on moon. Next slide. So these are some of the other more astronomically challenging advanced satellite programs that we have. One is the Disha Venus orbiter mission. Then we have the Mars lander that is going to come up. Next slide, please. And this is how we are going to evolve from Earth, colonization on Earth to colonization on Moon. Ultimately, by 2040 or 2047, we should have our own base where we will have an habitation on Moon, which will be something similar to whatever is there on the terrestrial. Next slide, please. And this is how some glimpse about the Gaganyaan program and how our Gaganyaan mission would be carried out. We have the launch vehicle on the left side, and we have on the right side we have the crew module. Initially we will have 2 crew that will go into the orbit, and this is how you can see the trajectory there, how the launch vehicle takes up, puts the crew module in the orbit, and then how crew module is recovered. That's also shown in this figure. It will land, it will touch down in around India, in one of the in the Indian Ocean, and from there it will be recovered. Next slide. And now you see, as we move, we go to a situation where we have more and more satellites in the orbit. Then there's a chance, like, they could collide, like what you have in the traffic jams on road and where you will have accidents. So something similar will be the situation when we have more and more satellites in the orbit. And not only satellites, we could have some asteroids coming closer to Earth. You must have heard about this DART experiment. DART experiment was carried out by US, where they diverted an asteroid entering into, coming closer to Earth by launching and hitting that asteroid so that it moves away, the asteroid moves away. So these are the kinds of challenges that are going to come in future, and we are gearing up towards this. Next slide, please. And these are some of the analysis that goes into identifying the debris that are going to come closer to our satellite. Next slide. Now coming to the private industry. See, earlier it used to be that only you could contribute in the world, in the space science, space technology only if you join ISRO. That's not the case anymore. You can join many of the private companies which are going to come, which are also contributing in the field of science, space science, especially the space science. Then to enable that, enable for all of the private industry to participate in the space technology, Government of India has come up with some arrangement. We have the InSpace, which is the authorizing agency, and is a single window agency where all space aspiring companies can benefit by going through them, and all of ISRO facilities are available for the private companies to take up. So why I brought up this point of private companies here is to just pass on a point that it is no more restricted to only ISRO. All of you can contribute in different ways. And this does not only include only scientists. It's not that only scientists can contribute in the field of space technology. We will need lawyers, we will need economists, we will need MBA who can manage big projects. So we have openings for everybody. Everybody can contribute in the field of space technology and astronomy. Next slide. And this is, of course, the economic conditions that are going to be there by 2023. That's what is envisaged. When the private participants are going to be there, we will have a huge economy. Next slide, please. And we have the New Space India Limited, where we are having a lot of collaboration with the private participation, so that all of us together can take the space technology in India to a greater height. Next slide. And these are some of the applications where we can, each one of you could contribute in future. Next. These are some of the private companies. Next slide, please. Next slide. Yeah. Now this is where I come to end of my presentation. I just want to emphasize on just 2-3 points. One is, we have no boundaries in thinking differently. Be innovative. This is what I'm going to tell. We don't have to follow anybody. You don't really have to go by what somebody else says. You can do your own research. Try to question everything that you see around you. That is how our ancient astronomers have taken up and introduced us to this wonderful area of space science. So it is very important that all of you please document whatever you are doing. The one basic message which I would like to give here is, please document, develop the habit of documenting. This is very important. Right from now you should start documenting things. Then it will be very useful for the next generations and future future generations to take it forward. And there is no limit for your thinking. You can imagine anything and that will happen. Nobody ever thought that one day we would be landing on moon. But we did it. When we started, maybe we never thought about it, but now it's a reality. So there is no limit to your aspirations, your innovative thinking. You are open to the best technologies that are available in the world. Okay? With this, I would like to conclude my talk. Thank you very much. I hope I have not exceeded time. Thank you. If there are 1 or 2 questions, we can take up. Otherwise, we will discuss maybe over lunch. Thank you.
Thank you, sir, for the valuable talk. I wish students will benefit from this. I now request Dr. Kriti Srinivas from MIT to present a memento to Raghavendra, sir. Madam, I request you to talk to the students.
Good morning, one and all present here. On behalf of organizing committee from Maharaja Institute of Technology with Karnataka State Open University, I, Dr. Kriti, Associate Professor, MITM, extend a warm and respectful welcome to all the dignitaries, distinguished faculty members, dear guests, and energetic students who have joined us today from various colleges of Mysore. It's indeed moment to immense pride and honor for me to stand before you for this prestigious celebration of National Space Day organized by Indian Space Research Organization, ISRO. I express heartfelt gratitude to ISRO for giving this remarkable opportunity to be a part of such an inspiring event. As a session, Aryabhatta 2 Gaganyaan by our esteemed ISRO expert was truly enlightful and inspiring. We are deeply grateful for sharing their valuable insights. It's truly motivating to see how far we have come and how much we have ahead. So, we come together for celebrate the National Space Day. Let us take a pride of India's achievement and be inspired for carrying this legacy forward with a passion and purpose. I once again thank ISRO for this constant support and this incredible platform. A special thanks to Srila sir from ISRO and Niranjan sir from KSOU for giving this opportunity. We today program and grand success. I request everyone to present here to make most of this occasion, learn, concentrate and be inspired. Thank you very much.
Thank you, Madam. Now let's have a glimpse of our nation's upcoming prestigious Gaganyaan mission with a video.
The wonders of space have always captivated humanity. For the maiden Indian human spaceflight mission, Gaganyaan, ISRO, in collaboration with the Indian Air Force, selected the crew from a pool of talented test pilots. These pilots underwent a battery of clinical, aeromedical, and psychological tests. Finally, the National Crew Selection Board recommended 4 test pilots from the Indian Air Force for the Gaganyaan crew training program. The selected crew members were trained at the Gaganyaan Cosmonaut Training Center, Russia, for a period of about 13 months. This training covered various aspects of a space mission, such as parabolic flights, survival training in off-normal snow, desert, and water landing, as well as extreme environment stresses. After returning, the astronauts are being trained in a newly established training facility. Through the Gaganyaan crew training simulators, mock-ups, and state-of-the-art virtual reality tools, the space crew is also getting trained in various human-centric products and survival scenarios. Physical fitness of the crew is maintained through a rigorous physical training regime. A specialized yoga module is also incorporated in the physical training curriculum for holistic health management of the astronauts. They will also be assigned for ISRO NASA mission to the International Space Station, announced by the Honorable Prime Minister. This incredible feat will take Bharat to greater heights. Akasha, Bhavantam Pratikshate.
I hope you all have seen Sudhanshu Shukla, who had been on ISS via Axiom 4 in this video. Moving ahead, today we have our esteemed speaker of this session, Dr. Nandini Harinath. She has 27 years of experience working at ISRO, specializing in mission design and spacecraft operations. During her tenure, she has held key positions in more than 20 satellite missions. Currently, she is a Deputy Director at ISTRAC, where she oversees the tracking and control of ISRO's low Earth orbiting satellites and interplanetary missions. Recently, she had led the operations team at ISTRAC, ensuring the successful mission operations of Chandrayaan-3, Aditya L1, and SpaceX mission. She is an eminent speaker and has delivered a number of lectures in schools, engineering colleges, and organizations. She is also a TEDx speaker. She has been in the board of directors of NIT Bhopal for 5 years, and she is a recipient of various awards. ASI Space Gold Medal in the year 2019. She is awarded India Today Women in Science Award 2015 and Delhi Commission for Women International Award in 2023. She's also awarded the ASI Team Award for Mars Orbiter Mission in 2014, ISRO's Team Excellence Award for Radar Imaging Satellite, that's RSAT-1, in 2012, and awarded the Team Excellence Award for Satellite Recovery Experiment. I now invite Dr. Nandini Harinath to deliver the talk on a sneak peek into ISRO's prestigious missions.
Okay, children, you had a tour of what ISRO is doing through our lecture given by Raghavendra sir. I'm sure you enjoyed both the videos, and I'm sure all of you have heard about the Gaganyaan mission, but you must have all wondered at some point of time how these astronauts are selected. And I'm sure many of you have thought about being an astronaut sometime or the other, isn't it? How many of you want to be an astronaut? There, see so many hands. Yeah, more hands are coming up. So if you want to be an astronaut, you have to be not only just physically fit, mentally fit, you have to undergo and pass so many tests that you saw today in that video. Are you ready? Okay. Okay, so today I'm here to speak about some of these very important missions that ISRO has done. You all know that satellites are used for so many things, isn't it? You have to say yes or no. Yeah, okay. In so many ways, we use satellite technology and we don't even know about it. And we take that so much for granted. How many of us actually leave our homes without the mobile phone? And, oh, you're not allowed to take mobile phone. Okay, fine, I understand. And what about internet? The entire information, everything is available on our fingertips today. So, a lot of that goes to the satellites. Now, can we move to the next slide? I usually like to start my presentation, especially if I'm speaking to children, or with this slide. You heard a lot in the morning, since morning, about ancient Indian contribution to science and more to astronomy. Have you all seen this Jantar Mantar in Delhi or Jaipur? How many of you have gone there? Yeah, I see so many hands again. So it's really amazing, and when you go there, what will strike you is how did ancient Indians or people who built it, they knew so much about the movements of the planets. It can tell you precisely what time sun is going to rise on any particular day and what time it is going to set without using any computer or mobile phone. You already heard about our ancient astronomers. All of you know about the place value system and the face value system, right? The rules for zero. All that, like Sir explained, came through our ancient Indians. Now, again, let us talk about navigation. So earlier speakers mentioned about communication. How earlier people used to communicate, put a fire, and so many pigeons, etc. What about navigation? Have you ever thought about it? So one analogy I can give was, have you read about this famous book called Meghadoot written by Kalidasa? I'm sure somewhere in your textbooks you would have mentioned it, even if you've not read it. But the story goes like this. Yaksha is imprisoned by the king and he wants to send a message to his wife. Yaksha is somewhere close to a place in Madhya Pradesh probably, and he has to send a message to his wife somewhere in the Himalayas. So one is to send a message, but how does the message reach her? He describes the route for the message to travel through this beautiful poem. He describes all the sceneries that one would see on the way. That is nothing but a concept of navigation that we have. I want to tell you, I reached Mysore and I reached KSOU today, but this campus is so huge, I didn't know where this auditorium was. So all I had to do was ask Srinath for the location and I reached here. So this especially the navigation, is something I think today we kind of, I should say, breathe in, breathe out, and we cannot do without it, this technology. So let me quickly go further. Next slide, please. So this current programs, I don't think I want to mention. We'll go to the next slide. You heard all about it in the previous speakers. Here, okay, this slide is important because today ISRO not only has satellites in the low Earth orbit, which will take very good pictures from space, but we've also reached a distance of 225 million kilometers. Our satellites have gone as far as that to Mars. Next. Okay, so this slide again is a kind of a repeat on how ISRO evolved from its early days to the present days. So what is the takeaway from this slide? I'll just say one thing. Let's say you want to buy a mobile phone. Most of us use the phone not just for talking, but for the camera, isn't it? You want to buy an expensive phone, you can talk actually with any kind of phone, but why do all of you want to buy more and more expensive phones? Because you want to get better and better cameras. Earlier, in the early satellites, from that altitude, we could image a location on the ground, and the best resolution we had at that time was 1 kilometer. So if any object or any place is smaller than 1 kilometer, it could not be detected from space. But today, we are able to detect a 25 centimeter object from an altitude of probably 500 to 600 kilometers. So we have such very good resolution cameras in our current satellites. Next slide, please. So my topic today was to talk about few very interesting missions. Have you heard of SpaceX mission? Yes or no? No, I'm not seeing any hands. Oh, so nobody has heard of both SpaceX. Okay, one. So this is a mission that took place this year, and it is very important because it involved two small satellites which docked in space, right? The two satellites were sent as separate satellites, and just a minute. They were injected as two separate satellites and they were going around the Earth. But at one point of time, they were brought together and they finally joined with each other, and we even did a power transfer between the satellites. Why is this important, this technology? Have you heard of this docking technology? Did you all see Subhanshu Shukla go to the ISS? You saw, right? So he went in a vehicle and that vehicle docked with ISS. Did you see the docking? Okay, I can see a few hands. Yeah, you have to raise your hands if you've seen. Yes, I can see that. Okay, so it is important because if you have to build a space station in space, or you want to send humans and they have to stay there for a longer time, you need another vehicle or another satellite to go and then dock, so that in order to build the station, and that person also has to come back after a certain time. So this was important and ISRO demonstrated this. Next slide, please. Yeah, you can see these are real pictures, no? They're not graphics or photographs. You can see the small satellites in orbit. Okay, and one satellite was captured by the other satellite. That's why this picture is important. Okay, next. So I will talk about a little, maybe about 5 to 10 minutes about Chandrayaan. So all of you saw the Chandrayaan mission happening, isn't it? Yes, raise your hands. Oh my God, everybody. Okay. So, so Chandrayaan was a mission that was very important because ISRO had to prove that it had the capability to land successfully on the moon. When I say land, land softly, land in one piece, and after landing, the satellite should have a capability to communicate, and also it had a small rover which came out of the belly of the satellite, which went all around the moon surface and took some had some instruments, and we got some signs out of it. So now this particular mission had multiple phases. We had a rocket, LVM-3, which took the satellite in an orbit around the Earth. All of you know we don't have a very powerful rocket that can take a satellite directly to the moon. So this rocket leaves it in an orbit around the Earth, and every time the satellite goes around the Earth, it fires its engines and gets a little more energy. Finally, it goes away from the moon's orbit towards, from the Earth's orbit towards the moon. So that was the series of burns that we did, that you see, series of Earth burns. And then as it goes closer to the moon, it has to get captured around the moon. So again, the thrusters and engines have to fire for it to get captured around the moon. And then came the most important part, the landing. So this satellite was going around the moon, the Chandrayaan-3. At one point of time, it has to brake, it has to reduce its velocity, and it has to come on an intended trajectory right at the point where it is expected to land. What is so challenging about it? As you all know, moon doesn't have any atmosphere, and it is hit by all these meteorites, comets, and the moon surface is full of craters and boulders. It is really hard to find a place which is very even, and any error in the landing could take you in a crater. And then it's almost, so once you land in a crater, obviously it's going to tumble. And so that is why it was extremely challenging. Next slide, please. So this is an overview of the mission. Next. Next, yeah. So let me skip this. Next. So this is how, this is a view of what is an animation of Chandrayaan-3. Next. Yeah, so these are some real pictures that we got from the satellite. They are not any simulation pictures, they are real pictures. As the spacecraft was landing on the moon surface, you can see a part of the solar panel and you can see a part of the moon surface. So like all of us scientists were sitting in the mission control room looking at the telemetry data and looking at all the parameters which were telling us whether it was landing properly or not. But for the common man and for ourselves also, ISRO was smart enough to design a camera which was sitting on the satellite, which captured a part of the solar panel, you can see. And this camera was sending us pictures continuously. Every 4 seconds, it was taking a picture, and within no time, that picture was relayed to the control center, and we were displaying for the whole world to see. So whereas we saw the telemetry, the whole world saw these pictures, and this became, the moon surface became more and more clear as it was landing and it was approaching the surface. So here you can see all the craters as it landed. And these are some of the pictures of the rover while it came out from the belly of the satellite. It rolled down and then it created some tracks on the moon surface. And the rover had a camera, the lander had a camera, and both of them were happily clicking pictures of each other, and we were getting all the data in near real time. Next, please. So I'll skip this. Yeah, I mean the rover, when it had to move on the surface of the Earth, it is not an easy job because there are craters and boulders everywhere, and this rover has 2 cameras which act as eyes. And we have to get the data on what the rover is seeing, and then move the camera. It is like what, all of you play with this remote control cars, right? It is like you are driving the car sitting here in the control center, but the car is on the moon surface. So you have to get this image and then decide whether to go straight or turn, but you have to be careful that you should not land in a crater. Next. Yeah, so this is the deep space antenna, a picture of the antenna that got all the signal from this satellite. Next. Yeah, this was the majestic rocket that took the Chandrayaan-3. Next. These are more and more pictures. The moon's surface, I told you, doesn't have atmosphere. There are no winds to wash away the tracks. And once there's a track on the moon's surface, it remains. And you can see the tracks that the rover made on the surface, and you can see some pictures of the crater. And we had some very interesting and nail-biting moments wherein, the rover had reached the edge of the crater. This is a story I like to tell. A conflict between the scientists and the engineers. The scientists wanted us to go close to the crater because that is where you get maximum science. Because all the material would have spewed from the crater and they will know max about what is inside only if they go close to the crater. But obviously the engineers are scared because if you have done any miscalculation, you will fall in the crater. So we had one such situation wherein we went very close to the crater and we turned 90 degrees and we saw another crater. Again we turned another 90 degrees. We saw another crater. Finally we had to retreat. So you can see like how the car goes in the reverse gear. You can see the rover did a back track and you can see 2 tracks on the surface. Okay, next. Yeah, so this was the situation I was talking about wherein we had to do a back retreat. Next. Yeah, these are some of, again, more pictures of the rover. Next. Yeah, so, India, this is a very proud moment for all of us and for all of you too. We had our flag and the Ashoka symbol on the rover and that moved around all over the surface. I don't know if you can see it. Yeah, there. Next. Okay. So, yeah, I was telling you about the pictures they were taking, the rover was taking the lander's picture, and you can see the lander, how majestically it's standing. And the rover has taken this picture probably, 50 meters or 60 meters distance. Next. Okay, so the rover moved all around. It collected a lot of signs from the surface, probably about what material was on the surface, what temperature was on the surface. There was another very interesting finding that we found, that within 10 centimeters of the surface, there was a temperature difference of almost 70 degrees. So you can estimate what kind of material the surface is made of. So these were some very interesting facts that we found. There were many, many such interesting facts. Next. Okay, so moving away from Chandrayaan, let's go to Aditya. Have you all heard of Aditya mission? Raise your hands. Oh, not bad. So this was a mission that was not literally going to the sun, but it was going to a very vintage point from wherein you can observe the sun constantly. So there's a point called the Lagrange point, wherein the forces of the earth and the sun, they nullify. And when a satellite reaches this Lagrange point, it can have a constant view of the sun. So this was one of the advantages of reaching this point. And again, this had lot of imaging cameras, and constantly these instruments are looking at the sun to know the dynamics of the sun. Like what is that material that sun is spewing? What is the magnetic field that is coming out from the sun? What type of plasma? And how often is this coronal mass ejection that we call is happening? Next. So I won't go a little more into detail because I want to talk to you about another mission. Next. Yeah, so Aditya also reaching that Lagrange point was not easy, right? You had to do a lot of maneuvers, and to know that you reached the Lagrange point itself was a very big challenge, because you have to determine the position of the satellite constantly and ensure that you are on the right track and reach the Lagrange point. Okay, next. Okay, this is the path that the satellite took, and this is the line that I was telling you between the Earth and Sun, and that is, the dot is the Lagrange point. Okay, next. Okay, so this is the next part of my talk, and I'll speak another 5 minutes probably on this Mars mission. I was lucky to be a part of this Mars mission, and you know, many people ask, why did ISRO have to spend so much money to go to Mars? So will you be just happy looking at Mars through your telescope or read about Mars in your books? Yes or no? No, right? You want to know more. So how do you know more? So one thing is ISRO decided that it will have its own mission to Mars, and there are many things about Mars that we do not know. Actually, Mars and Earth have a lot of similarities. A day in Mars is very similar to day in Earth, and we have seasons because of how the ecliptic is inclined, right? The Earth's orbit. So there also Mars has similar kind of weather and seasons like we have on the Earth. It's just that it's such a much farther orbit from the Sun. So there are only few similarities, but of course there are a lot of differences. And next. So the composition of the Mars itself is very different. And then people will ask, why do you want to know what is there on Mars? Actually, a lot of information that you get about Mars will tell a lot on how the Earth evolved itself. And then there is this $1 million question. I'm sure, given a chance, you're going to ask each of us, is there life elsewhere? Is there an auditorium like this in case, another case you somewhere in another world where a lecture is going on about outer planets and satellites? So this is a question which we all would like to know answers. Next. So this story of the Mars mission was challenging because from the time we got the sanction to the time the project had to be executed, we had only 18 months. Why? Because there is a launch window. If you don't launch within those 18 months, then obviously you will not be able to reach Mars, and it's not a very optimum way. Next. So here again, the journey of the satellite to Mars was extremely challenging. You know why? Because all the Earth, the Mars, the satellite, all of them are constantly moving. And if you have to find an optimum trajectory, that geometry will happen only once in that 18 months. And if you don't capture, and if the satellite doesn't reach Mars in that particular geometry, it is bound to get lost in the solar system. Next. So what did it actually involve? It involved sending the satellite away from Earth to reach Mars, and we were targeting a pillbox of 50 kilometers close to Mars from a distance of 650 million kilometers. Can you imagine that? Yeah, so this was precisely the challenge that we had. Again, the rocket was not powerful enough to leave us in a trajectory towards Mars. So the satellite did number of orbits around Earth, and every time gained energy, finally got that escape velocity to escape from the Earth's surface. But it also meant not just escaping, but escaping in the right direction at the right time, with the right velocity. So direction, magnitude, and time was extremely important. So there was this analogy which a lot of people gave, and this is also my favorite analogy for you to understand how difficult it was. This was like, you're hitting a golf ball, probably from Mysore, and the golf ball has to land in Washington in a bucket, and to make it worse, the bucket itself is moving. So that was a kind of targeting that had to be achieved here. Next. But that was not just one of the problems. There were many, many other problems. All these, the communication that, I'm speaking and you're listening to me, and when you raise your hand, I can see it. So we're having a good time because I can see the response real time. But what happens when you want to control a satellite which is around Mars? Just because of the sheer distance, light would take something like 22 minutes to reach Mars, and another 22 minutes for the same signal, because the signal travels with the speed of light, for it to come back to us. So there's no way you can control the satellite when it takes, like, imagine this conversation, I'm talking to you and you will hear me after an hour or 40 minutes, and then you will nod your head and I will hear. Can we really talk to each other? No, right? So this was a problem that we had, and the satellite had to have a lot of autonomy features for it to survive around Mars. And more than anything, you had to receive that signal from that 225 to 400 million kilometers amidst a gamut of noise, and the kind of precision that you need to have, the sensitivity of the receivers is extremely high. Like, it's like, catching a whisper sitting in a cricket stadium. How sensitive your ear should be if the whisper, somebody is whispering on the other side of the stadium. So that kind of receiver sensitivity this had. Next. Okay, so this is another very interesting story. I don't know how many of you know it, because I don't think this was really publicized. So, this life always teaches us this lesson: expect the unexpected. So right after all the planning, reviews, and the satellite had reached Mars, something very unexpected happened. There was a comet from outside the solar system, the Oort cloud, that reached Mars exactly at the time we had reached Mars. So, what do? The comets, all of you know, comet has a shovel, and any of this comet shovel hits the satellite, and the satellite will not be functional anymore. So we had to plan a maneuver so as to duck the comet. So as the comet passed, we did a maneuver so that the satellite was on the other end of the comet shovel, and just as the comet had passed, the satellite emerged from behind the Mars and took a picture. So it was a double dhamaka. Not only we escaped the comet, we got a chance to click a picture of this comet which came from the Oort cloud. Next. Okay, the Mars has many moons, and we could take pictures of these satellites of Mars, the Phobos and the Deimos. Next. Yeah. So this is one picture, we had a camera which could take the entire Mars disk in one frame, and this was one such picture. Next. Yeah, we can skip this also, these are more pictures. Again, next. Yeah, they say the proof of the pudding is in eating. You have reached Mars. How do you tell the world you reached Mars? Take a picture and transmit it in real time and say, okay, I have reached here. It's more like, when you go to a place, immediately you will put a story on Insta. So similar thing happened. Okay, we didn't have Insta at that time, but then the proof of reaching there was this picture that was taken immediately after the Mars insertion. Next. Okay, Mars is also home to a lot of volcanoes. In fact, the highest volcano in the solar system is on Mars. So this is some of the pictures of the volcanoes of Mars. Olympus Mons is the highest volcano. Next. These are more pictures of the craters on Mars. Next. Okay, this is, I think, my last slide, and I'll end with this. Have you heard of NISAR? Some people call it NISR, NASA ISRO, Synthetic Aperture Radar. Raise your hands. Okay. Oh, not bad. Okay, 50% of you have heard about it. So when was this launched? Okay, so yeah. So this was launched on the 30th of July. This is a satellite made by NASA and ISRO together. And NASA and ISRO have been collaborating on this project for a long time, almost 11 years now. And this can tell you everything about the Earth, the ecosystem. It can tell you how the polar ice caps are melting, how the tectonic plate is moving, how the waters is raising in the ocean, lots of things. So I just wanted to tell you, okay, this satellite is functional, alive and kicking. Next. 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 Okay, with that I end my presentation. I think I've taken a little more time than... Okay, thank you very much. I don't think we have time for questions, so what we'll do is I'll take the questions maybe after lunch or just before the quiz. You can also meet me anytime during the lunch break and I'll answer your questions. Sorry about not taking your questions. Yeah, but we'll be there around. Thank you so much for your attention. Thank you.
Thank you, ma'am, for taking us through this wonderful journey of our missions and keeping the session active. I request Dr. Subramanya Ganesh, DD NSA, to present a memento to Madam. Thank you, sir. T.S. Shivaprasad, presently working as General Manager at LPSC HAL Work Center at HAL Aerospace Division. He is from LPSC Bangalore and he has graduated from NIT Surathkal. He is an expert in realization of miniature components for spacecrafts and realization of propellant tanks for launch vehicles, PSLV, GSLV, and LVM-3. He has conferred with Team Excellent Award from ISRO and Ankit Award from Society of Aerospace Manufacturing Association. He has presented many papers in national and international journals and conferences. I now invite Shri Shivaprasad to provide an overview of ISRO launch vehicles.
Hello. Namaskara. Good morning. Respected AD stack and all my dignitaries of the dais and my dear ISRO employees, ISRO friends and teachers and my dear students. Once again, good afternoon to all. Now good morning, good afternoon. I am giving the overview of various launch vehicles of ISRO. Okay, next slide. This is the general our organizational structure of ISRO, just to show you that how our organizational structure of ISRO will work. It is reporting directly to our Department of Space is reporting directly to Prime Minister, and the Department of Space, Indian Space Organization will come. And we run various centers like ISRO, VSSC, URSC, LPSC, ISTRAC, SAC, HSFC and all. Okay, next. So how do we go to space? See, actually, so everybody, children, particularly you people, when you see the birds and all, you feel to fly, no? So how do you want to make a fly? So we'll have different types, human from the beginning, no? They used to have wings, gliders, balloons and all to fly in the space. This is one of the beginning of our space journey. Next. So what is the principle of, I can tell, what is that, for every action there is an equal and opposite action. What is this? Newton's? Yeah, exactly, yes. It is Newton's third law. It tells that for every action, good, very good. So this shows that how it works. Suppose if you fire, no, so that hot gases will expel, and for that reaction, that the bottle moves forward. Same principle has been used for the rockets. Okay, next. So this is the one. Next. So already our AD has explained, our ISRO has started its journey from church at Tirunananthapuram, where the beginning of our ISRO programs have started. Initially, people used to carry rocket parts on the cycles and satellites on the bullock carts. Okay, next. These are the evolution of our launch vehicles. It starts from SLV-3, ASLV, PSLV, GSLV, LVM-3, and that human-rated launch vehicle, and for the Gaganyaan also. Okay, next. So I'll come to all these things one by one. Next. So this is the first rocket made by ISRO, that is, there has been Rohini 75. This was the first rocket and launched from Tumba, and the weight is around 10 kg only pay weight, and altitude 4.2 kilometers. Next. And can you recognize the person? Yeah, who don't know, otherwise no. Children should know, and you all should aim to go to that position. So Abdul Kalam, Dr. Abdul Kalam, so he is the PD for the first satellite, launch vehicle at SLV-3, and this is done in August 2019 and weighing only 17 tons and payload around 40 kgs. After that, we have developed another launch vehicle called ASLV, that is also weighing around 39 tons, and payload is only 115 kg. This will be, please note down, you see how much payload has been increased over a period of time, our capacity. Next. So these are the different classes of launch vehicle, and we segregate like this: 2.8 meter class and 4 meter class and above 4 meter class, like this only. So 2.5 meter class, go back, 2.8 meter class will comes around PSLV, GSLV. These are all 2.8 meter is the diameter of the what you call this tanks or the rocket. And whereas 4 meter class also, now we are doing LVM-3, that is the size of the propellant tanks. Okay, next. So this is the propulsion system what we use for the rockets. One is earth storable, that means you can store the propellants in the atmosphere. Whereas other one is called cryogenic, where cryogenic is what we are right now using is a LOX, that is liquid oxygen and liquid hydrogen. These propellants has to be stored below minus 270 degrees centigrade. So handling of this propellants is really challenging. So that's what is called cryogenic, which gives the high pulse impulse, so that we can take the satellite to the highest 36,000 kilometer orbit. And other one is semi-cryogenic that we are developing in India. So we are going to achieve it very fast. Very shortly we are going to develop semi-cryogenic engines also. Next. What is, anybody can tell? What is the spaceport of India? Good, it is Sriharikota. It is near Chennai. Okay, this is a place where all our rockets has been launched. Okay, next. So coming to Polar Satellite Launch Vehicle. Next. So this is the specification, or what we can tell is this Polar Satellite Launch Vehicle is called as a workhorse of ISRO. That means we are depending upon this, and this is working like horse only. So many satellites is launched and there is no failures except one or two only. Initially first one was failure and recently also one failure. Otherwise all the launch vehicles were success only. And this is having 4 stages, 2 solid stages and 2 liquid stages. And height is around 44.44 meters, and this is called I1K, that means you will take the load of 1.4 tons of payload to the space. Next. So this is what I am explaining. There are 2 stages, 4 stages. First stage is called PS1, that is a solid stage. And second stage is a PS2, it's a liquid stage. And third stage is again solid. And fourth stage is again a liquid stage. Okay, next. These are specifications. Next. So this one video you can see how the launch will.
Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Lift off normal. After you tracking? tracking. First stage performance normal.
This is the actual launch of PSLV C-59. Okay.
Airlift strap on ignited. Strap on separated.
Next. Good.
5, 4, 3,
No, one more launch. Can, because
one,
of claps, no?
0,
Our friend want to put one more launch for you, guys.
5 seconds.
Lift off normal. You are tracking? P2 tracking. P2 tracking.
Tracking.
Stage performance normal.
This is onboard camera. See, we have put the camera on the spacecraft, launch vehicle itself. We can see how from the launch vehicle you can see this is the satellite is being injected into the orbit. The real camera photos, videos. Okay, next is one more important launch vehicle is GSLV, that is a geosynchronous launch vehicle. This is mainly used for putting the satellite in the geosynchronous orbit where all the communications payloads has been injected, around 36,000 kilometer orbit. Okay, next. So the weight is around 49 meters, and the specification, generally you can see all these things. This is mainly 3 stages. And you have 4 strap-on motors. This is called L40 motors. These are all liquid engines. And unstorable liquid engines only you are using for all the strap-ons. And one middle is a PS2, that is again a liquid engine. And top is a cryogenic engine. This is called CUS engine. So this is one which is indigenously developed by our present chairman, Dr. V. Narayanan. He is the father of this cryogenic engine. I am proud to say that this has been developed indigenously by LPSC. Okay, next. So these are the specification of our launch vehicle GSLV, 73 stages, first, second and third stages. So where it is using the third stage, we are using the LOX and LS2, that is the liquid cryogenic fuels, what I already told. And second stage we are using UL, that is again a liquid engine. And that we are using US-25 and N204. And initially, first stage is the solid propellant. First stage is nothing but a solid propellant, means you would have seen the Deepali rockets, no? So how the Deepali rockets, once you fire, no, you cannot control. Simply go, you cannot control till it reaches. Like that only first stage will work. Whereas second stage and third stage, it is a liquid engine, it's like a Nallitara. You can stop anytime and again open it again, launch again. That's the advantage of liquid engines compared to solid propellants. Okay, next. This is the overall view, the exploded view of a rocket. It's from the outside if you see it looks very big, but this overall inbuilt parts of a GSLV rocket. Okay, next. So one more launch we'll see, GSLV launch. This has been recently, 30th June been made, nicer launch. Recently, 30th July, this has been launched successfully. This is a Nationl launch. Costliest satellite, 13,000 crore satellite. I can clap.
All L40 engines generating nominal thrust. S139 motor ignited. PC tracking. Lift off normal.
See how majestically it is going. You have to be there. You can see all these launch physical. You also can see if you come to Sriharikota, there is a program for all the public also. I'll inform you later.
25 seconds.
This is onboard camera view. The actual view, so you can see the 4 stages has been separated. The interstage burning started now. The heat shield, the top portion heat shield is like separated. This GST separation, the second stage got separated because ignition has taken place. You can see this ISRO satellite has been injected successfully into the orbit. It's a great thing. Okay, next. Next. Okay, coming to LVM-3, you would have seen the film of Bahubali. Not here, very good. So, on this vehicle, this is LVM-3 now Bahubali and Kariti. It is a Bahubali of ISRO. This vehicle is called Bahubali. Okay, go to next. This just gives overall picture how it looks internally. So it is having a two solid propellant rocket boosters on the other sides. Center one is called L110 liquid stage, and the next one is called G25 cryogenic engine, and above that only payload will call, or flankings will call. Inside we have put the satellite. Right now here we are showing the Chandrayaan-3 satellite has been put. So that video only I am going to show you. The LVM-3 is taking Chandrayaan-3 to space. Okay, next. The same thing only. Okay, next. So this is the overall specification. Around height is around 44 meters. Is short but bulky, and weight around 648 tons, and the capacity is 4 tons to geosynchronous orbit. This is the capacity of this rocket. Next. The overall specification. So you can see this, note down. So 2 solid boosters are there, and two liquid engines, L40 and centers L110 engines, and 2 solid boosters S200 and C25 cryogenic upper stage. Okay, next. Now we are upgrading to C32. Okay, next. This is our launch pad. So you can see this is for Chandrayaan-3. Madam just now explained how the Chandrayaan-3 has how it is landed. So I am taking the satellite to first, then only to landing in there.
3, 2, 1, 0. Plus 5 seconds.
Lift off normal, pure tracking. Auto tracking. Auto tracking. Stage performance normal, before tracking. L110 stage ignited.
Plus 2 minutes.
L110 stage performance normal.
That is a separation. You can see the separation of 2 boosters, solid boosters.
200 stages are separated. Off-load guidance initiated.
The onboard camera view. You can see 2 S200 getting separated. You cannot see physically, only this video only you can see. The flarings or heat shield got separated. And finally Chandrayaan-3 separated, injected into the orbit. The great thing, so this is it has to be written in the history. That is the way we are celebrating this day also. Okay. Next. Now coming to next.
5,
SSLV.
3,
This is a small satellite launch vehicle. This is recently developed, now in our development only. This is for launching small satellites to lower Earth orbit.
tracking, tracking.
And turnout days is hardly 1 week or 2 weeks only. Within 2 weeks we can make this launch vehicle ready for launch.
Plus 40 seconds.
These are all real for videos taken from the launch vehicle. This is satellite being separated. Okay. D3. Next. Next. Coming to Gaganyaan, already our AD explained and Madam also explained, this is our Indian ambitious mission, Gaganyaan mission we are going to take up. This is the one we are going to use the LVM-3 only, but human rated launch vehicle. So this vehicle should be rated for the human because we are carrying our own astronauts, Indian astronauts will fly this. And it's having a crew model where satellite is to sit in the top, no? So there we are going to put this crew model. This is having two things, one is service and orbital modules will be there, and where astronauts were going to sit. Next. This is a specification overall, right? Earlier we were planned to send 3, now I think only 2 will be going. And purpose is to take the 2 or 3 Indian astronauts to space, around the 400 kilometer orbit, circle around that 3 to 4 days and come back. That is the main intention of this, objective of this Gaganyaan mission initially. Then slowly we will develop in a different, to go to the moon, get down, collect the sample and come back, and after later on go to other planets also. Like that, future we are having a lot of plans in our ISRO. Next. This is how it works, already explained. Next. Next. These are parts, what you can see, the one is the tested one, we have one model you can see how Inaugural is done, and service model recently is tested successfully. Now we are ready for all the proposed systems are qualified for this Gaganyaan successfully, so we are going to go ahead with this very shortly. Next. This is how that trajectory is showing. So we are launching the LVM-3, that is human rated launch vehicle, going up to 400 kilometer orbit, and it will be injected and it will goes around the earth around 4 to 5 days or 5 to 7 days, and it comes back and splash down on the sea, and our Indian Navy will go and collect, bring back the astronauts back. Initially this will be there. This is the plan. Next. So for that, we are having different test. This is called TV, D1.
7, 6, 5, 4, 3, 2, 1, 0.
This is called pad abort test. That means astronauts will be sitting, suppose something happens in the launch pad itself, or once it launches, we have to take the astronauts away from the launch vehicle to be safe. For that only this test has been done. So up to some kilometers, if anything happens, immediately test can be aborted, and the crew model will come out and safely it will be landed by parachutes. So like these parachutes will be there, so safely it will be landed. So you have to take the safety of astronauts. Okay, next. Similarly, test, this is only development only. This is the DVD1. It's called Test Vehicle Developmental Version 1.
Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
TVD1 का सफलतापूर्ण प्रज्वलन तथा प्रमोचन मंच से
This is also successful and we are ready now. Okay, next. Next.
7,
Next.
6, 5,
My friend wants to show you once again.
2.
Next. Okay, this is the recovery module. How after that test, what you see, that crew model comes down and splashed into sea, and it has been recovered by our Indian Navy and with our friends, and the photo shows it was recollected from the sea. Next. This you would have seen, no? Many of you know this. Can you tell anybody what is this? Recently, SpaceX and Axin-4. So our Indian astronaut who has gone in this. Who is the astronaut gone to ISS, the International Space Station? Shubhanshu Shukla, yes, very good. Next. So here are the 4 astronauts. You will call as Indian Gaganyaan 3 has been selected. And one of them, last one, Shukla has gone to India. He is the first Indian to go to Indians, also International Space Station, and safely came back also. Next. Next. These are the 4 crew members gone to India International Space Station, along with 3 our Indian Mr. Gaganyaan Shubhanshu Shukla also flown and came back safely on June 25th. July 14th he is returned. Yeah, thank you. Next. So these are the future launch vehicles under development. Already SSLV has shown the launch also, that is under development, only D3 is made. Now we have to make it operational. And similarly HLRV, that is human rated launch vehicle, is under development. And RLV, already sir has shown this photo, and here also we are planning to bring back like a space shuttle, like a plane will come and land on the earth. That's also a planning. Next is NGLV. There's a new generation launch vehicle, that is only future launch vehicles of ISRO, that is under development. So next. So we are using a different green propulsion, because what all I told, it's not good for health, human. So we want to develop a green propellant where it is not affecting the human who are traveling. That will be useful for the future human missions, man missions. Okay, next. This is a reusable launch vehicle. They are already tested RLB, what already we have seen the photo also. Next. This one I want to tell, this is a new generation launch vehicle. There is a lot of demand for that. All our launch vehicle present will be replaced by this in future. So we are going to take up this launch vehicle development. It's under development stage. Next. And the diameter of the launch vehicle is varying from 5 meters to 7 meters. And height is around 86 to 90 meters. It's a very high weight and height. And it's able to take 23 tons of payload to LEO and 9.6 tons to GTO. And this is having we are using a different propellant that's called last methane propellant, and we are going to use this for our future, for Bhayakas, that is our own Indian Antariksh station. We are planning for that. We have to carry all the modules, no future, so it will be taken care. So next, we want development only. So this is our aim and this is our ambition. So future we should have our own Bharatiya Antariksh station. That's all. Next. Okay, this for the students, okay, it's not out of this. Just many of you are interested to join ISRO after seeing all these things. Who are interested to join ISRO? You want to become astronaut? Yeah, good. So for you to join in future, you have to study engineering or any course, and there is various methods or path is there how to go and join ISRO in future. So that is very different methods. One to go and JE means or go to engineering stream, then come write an ICRB into this national level exam and join ISRO, you attend into. Okay, next. Not only for engineering students, even for the non-technicals also we have the opens. That also you can pursue. Don't think that okay, only for engineers only can join. Your medical, administration, accounts, commerce, anybody can join ISRO. Having a different, all the people are required for development. You people only required. Okay, next. Yeah, thank you very much. So I think I will take more time. Thank you, and questions I think we can take up later also during the. Thank you very much.
Thank you, sir. We have one more talk. Students, I request you to please be seated. I now request Dr. Prithvi Rani to present a memento to Shri Siva Prasad. There is one more lecture. I request students to be please seated. And now we have a lecture by Srimati Nagalakshmi, Project Director, Anvesha Mission from URSC.
ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. All my dear children, I think ಎಲ್ಲರಿಗೂ ಹೊಟ್ಟೆ ಹಸಿತಾ ಇದೆಯಾ? Only 10 minutes. I think this is the last lecture. So I will conclude within 10 minutes. I know ನಮಗೂ ಹೊಟ್ಟೆ ಹಸಿತಾ ಇದೆ. So we'll try to conclude at the earliest. Okay? Very good afternoon to all the dignitaries and my dear students and all the faculty members who are present here. And ಇವತ್ತು ನಾನು ಮೈಸೂರಲ್ಲೇ ಹುಟ್ಟಿ ಬೆಳೆದವಳು and I am very happy to be here and I am thankful to the organizers that my school where I studied could be accommodated and all the students and the faculty are here and I am so proud to be here and I will not miss an opportunity to be always available at Mysore whenever they are called. So I request all the students to be seated for another 10 minutes. Yeah, my topic is Introduction to Satellite Systems. And I have written it is only an introduction because the satellite system itself is so involved and each subsystem is in itself a 2-day topic to be spoken about. So, you noticed a launch. Our colleague showed so many launches. So, these launch vehicles will be carrying what? Anybody? These launch vehicles will be launching satellites. So, these satellites, anybody knows these satellites are built where? These satellites are conceptualized, designed and built in which center, and the center is situated where? Anybody? Yeah. So, I will take you through how a satellite system is built and what are the subsystems of a satellite system and how tough it is to have all the features which will make a satellite system robust so that it will work as it is intended. Next. This was already told that the main vision was that we must be second to none in the application of the advanced technologies to the real problems of the man. So all these satellite systems, rockets and the ground systems, whatever we have established is for the societal usage. Finally, adu common man ge use agbeku. Whatever we launch should be finally used for the societal benefits. So this is the main intention. Next. And this is our initial days and our earlier speakers told that from this to where we have already grown. Next. So these are the centers of our ISRO and we know, as I asked, these satellites are conceptualized, designed and built at URF Satellite Center, Bangalore. So what all launches you saw? So these launches carried satellites. These satellites including Chandrayaan and the recent NISR, everything was built at URF Satellite Center. Next. And our space satellites will help in many applications like satellite communication, earth observation, navigation satellites, space exploration, space commerce, and we also already spoke about launch vehicles. Next. Space system segment. See, overall space segment is having 3 things. One is the space segment. Next. Another is the launch segment. The third dimension is the ground segment. See, we have to build a satellite, launch, and finally we have to use the services of the satellite. So that is the ground segment. Whatever data is recorded or whatever data is produced by the satellite needs to be downloaded and finally it needs to be used by the user, or it has to be used for the common purposes. So that is the ground segment. So today I will be concentrating on the space segment where we need to build a satellite for the usage of the common man. Next. So space systems are vehicles and the infrastructure working together to perform a task in the space environment. As I already explained, there are three verticals: launch segment, space segment, and the ground segment. Next. See, why do we need satellites? So what are the satellites, what all the works or what all the intentions of the satellite? Can we not do it otherwise? So satellites are very much required because they are cost effectiveness as compared to the terrestrial systems in certain applications. It is a distant independent communication links. It is a possibility to have the large coverage area, ease of configuration and expanding the networks, and observation of very large areas. So when we launch, we can have an observation of very large area, coverage of land masses that are not our own, and scientific missions are also possible. Next. So there are different satellite variants, like for Earth observation we use satellite communication, navigation satellite, and space science, and we already know that what are the different vehicles used in order to launch these different satellites. Next. See, spacecraft system, we all know that launch vehicle is for the satellite. Without satellite, launch vehicle is of no use. The same way, in the spacecraft system, we have two parts. One is the bus system, another is the payload system. Payload is, the satellite is built for the payload based on the requirement of the payload. Next. See, spacecraft design is governed by the payload configuration, power requirements, launch vehicle aspects, spacecraft platform and the stability required based on the mission for what we have to use, mechanical and thermal aspects, assembly and integration, and on-orbit life and the mission requirements. Can anybody tell that what is a payload? Some people would have come in car. For a car, which is the payload? Yeah. People who are sitting in the car are the payload for a car. So, for an aircraft, people and the cargoes are the payloads. Without them, either a car or a aeroplane will not have any meaning. The same way, for a spacecraft, payload will have the meaning. Payload is an instrument which will define for what I have to launch a satellite. Next. The preliminary design drivers of a spacecraft are mass optimization, because we have to see that how much a launch vehicle can lift, and maximum utilization, how much space is available for my satellite to sit on a launch vehicle, reduction in cost, because how much reduction in cost is possible so that we can put more utilities, increased reliability, convenience of system integration, how it is possible to have a easier system integration, optimal use of power, enhanced onboard autonomy, adaptation of state-of-art technologies, and the time frame defined by the mission. Next. Spacecraft, as I already told, spacecraft is divided into two things. One is the payload system, another is the platform system. Payload is a part which realizes the services justifying the mission. So for what I am launching a satellite, the instrument will be designed based on the requirement for which the satellite is being designed. And the platform system is a part which provides resources required for the payload. And the spacecraft will have a payload. It can be an experimental payload, communication payload, or a optical payload. And the platform will have a structure, mechanism, propulsion, thermal control system, telecommand, telemetry, and communication and control systems. Next. So the overall space system, spacecraft design drivers are, spacecraft design is driven by the payload or the mission. And as I already told, based on what are the payloads or what are the mission requirements, and we have to build. And there are some challenges based on this. Constraints on the lift-off mass, capability of the launch vehicle, physical accommodation, available volume and layout, power generation, solar array size, energy balance and battery sizing, and handling the thermal dissipation. These are the constraints which define how I have to design a satellite. Next. Building a satellite and to be ready for launch involves configuration, design, manufacture, testing and integration, and it requires specialized knowledge in various engineering disciplines. We have to adhere to strict quality control standards. And satellite consists of many subsystems. As I told that, we have to provide all the resources required for a payload so that it will work as intended by the mission. So subsystems are required in satellite to divide the complex tasks of operating a spacecraft into manageable smaller tasks. Each subsystem has specific function and they all work together to ensure that the satellite can perform its mission. This modularity simplifies design, analysis and maintenance, enabling efficient operation. Next. See, I have put what are the subsystems and how we can compare with our own body structure or whatever it is. These are the subsystems which are very much required, and this will provide the required resources for the overall satellite to function. So payload systems, as we know, it can be a science payload, it can be a communication payload, or it can be an imaging payload. And it requires a structure. Satellite requires a structure, an outer frame to accommodate all the subsystems of the satellite, and it needs to be sturdy, flexible, lower weight. So our structural system we have to have a design so that we can provide a total sturdy environment for the satellite. And thermal control system has to provide the thermal system design should be such that all the subsystems should work between the defined thermal levels so that we will not end up into any catastrophe. And thermal deployment mechanisms are the mechanisms like solar panels or any other movable parts. How do we design a movable part which needs to work remotely in space without any human intervention? So that is the deployment mechanism. And the propulsion system, as our colleague already spoke, the propulsion system will provide a fuel for the satellite so that it can work uninterruptedly in space. Next. Composite systems are the material which we use in the satellite so that it will give a safe environment to the satellite. And pyrotechnic devices are the devices which will be used for the deployment mechanism, where it will be used as either the cutters or a heater element so that we can have a safe deployment. And power systems, you know that power systems are very much required because we have to generate power, we have to store power, and we have to distribute power. So for that, we need power systems. And digital systems are required to have the telemetry, telecommand, and the other HK related parameters so that we overall will know what is the health of the satellite. And the communication systems involve all the antennas and the related electronics which will give us the total communication to the satellite. Next. And we need to have sensors because satellite need to know what it is looking at. And we can see that whether a satellite is looking at where it needs to see, or we have to maneuver the satellite so that we can have the satellite oriented to have a proper vision. And inertial systems will tell a satellite where it is with respect to a specific body. So inertial systems will always tell that the satellite needs to be oriented to a particular position, or it is already there in the intended system. And the control system will take all the inputs from the sensors, and it will decide whether we need to maneuver a satellite to have a proper mission, to have a proper payload working. Next. See, whatever I explain now with respect to each subsystem, these subsystems have their own work to be done, or we have to have these subsystems needs to be conceptualized, designed based on the mission. So once we have to start with respect to a satellite, we need to know that what is the mission, what is the payload needs to be accommodated onto a satellite, and based on that we will decide what all the subsystems we have to have, and the design of each subsystems, how many sensors we need to have, how many inertial systems, what type of inertial systems, what type of control system we need to have, power distribution, how much is required. All these things we have to decide based on the mission requirement. I think all these things we spoke already with respect to each subsystem. Next. 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 And these are a fleet of satellites from the beginning and at present, and these all satellites have been conceptualized, configured, designed, tested and delivered to the launch vehicle for a launch. And all these satellites are built and delivered by URF Satellite Center at Bangalore, and approximately 122 satellites plus counting with respect to the number of satellites. What all prestigious launches we see, all the satellites have been configured and built at URF Satellite Center, Bangalore. Next. And this, all the speakers who spoke before me and what I told about the satellite system is possible by Team ISRO, which is thriving for achieving the impossible. So, we always know how to manage with limited resources, and we have a never give up attitude and high integrity, team spirit, equal opportunity and highly motivated. And we all know that a team is not a group of people, but a team is a group of people who trust each other, and we know that whatever project or whatever work we take up will be completed. Next. Thank you so much. And
Thank you, ma'am, for taking us through the various subsystems of the satellites. I would now request Sri Abhishek A.S. from Gravity Science Foundation, Professor Selva Pillai Iyengar from KSOU, Sri Santosh from Mysore Science Foundation, and Mr. Kishore from LPSC to please present a memento as a token of appreciation to Madam.
And I have one final thing to tell all the faculty members here from each school. There is enormous outreach program from ISRO, and I request all the members to go through our website and encourage children to be part of it. Thank you.
We must find time to stop and thank the people who make a difference in our lives. This was told by John F. Kennedy. May I now call upon Ms. Hemlata, Group Director, ISTRAC, to thank everyone who has lent a helping hand to this program.
Good afternoon, children. I know all of you are very hungry and waiting for the lunch that is being served. Okay, just I'll take 2 minutes of your time. Please be seated for 2 more minutes, please. I request you. Okay. I am very happy to stand here because I am the alumnus of this Karnataka State Open University. In 2012, I completed my MTech and came here for convocation as a student, like all you people are sitting here. I was sitting somewhere at the back, and today I am standing here in front of you, giving a vote of thanks. It's a privilege for me. I thank Director ISRO, Dr. A.K. Anil Kumar, who gave his moral support and encouragement for organizing this event in a very grand scale. Director URSC and LPSC also, who supported us. Our Associate Director ISRO, Sri M.R. Raghavendra, who graced the occasion as a chief guest in spite of his extremely busy schedule. We know how busy he is, and he also gave a lecture on overview of ISRO journey, Aryabhatta to Gaganyaan, ancient history to infinite possibilities. Shri Jaswinder Singh Kural, chairperson of the NSPD main committee, reposing confidence in ISRO for organizing this event, and also spoke about the significance of NSPD. The Vice Chancellor of Karnataka State Open University, Professor Sharanappa, we will say, for gracefully providing the venue and jointly participating in all the events, giving us the full support. Then University of Mysore Vice Chancellor Professor N.K. Loknath for being among us and supporting with his keynote address. Registrar of Karnataka State Open University, Professor Naveen Kumar SK, and also Anant Kumar Registrar Evaluation, who are among us. Dr. Kriti Srinivasan, MIT, who addressed the gathering. I think all of them require a round of applause for doing all the support. And Dr. Nandini Harinath guided the local organizing committee and provided the strength for all of us to organize such a mammoth event successfully. Okay, and Mr. Shiva Prasad, General Manager LHWC LPSC, who provided the overview of ISRO launch vehicles. Srimati Nagalakshmi URSC, who spoke about ISRO satellites. So I hope all of you got a full insight of activities of ISRO after this program. Then PVN Murthy, Cell Head Visual Documentation and Outreach Cell, MDOG, URSC, who came along with the Space on Wheels as soon as we quickly accepted our request and came to Mysore along with the Space on Wheels. I know all children will be very eager to go to our bus Space on Wheels and see all our exhibits and also the exhibition. All the schools, principals, teachers who have mobilized the students and students themselves who have come here to understand our Indian space programs. Srinath, who I established the contact with KSOU and successfully managed everything. Shankar Madhaswamy, who arranged the models for the exhibition, and other team members, and Seena Sunil and Durga Rao Fistrak for arranging the transport for us to come from Bangalore to Mysore. Early in the morning, all our drivers came. So that was a wonderful arrangement. And also Mr. Niranjan and team from KSOU for arranging the most important aspect of the full arrangements and lunch, breakfast. Inchura and team for giving the invocation, and Bertley Ashley, who will now who has lined up a quiz competition for the students. I think all of you are waiting eagerly for that.
So I hope I have covered everybody, and if I have missed anyone, please excuse me. Thank you very much. It was a wonderful event for all of you here. Thank you. Jai Hind. So we have come to the end of the first half of today's session. I invite everyone for the lunch, which is very graciously hosted by ISRO at the basement. I request students to assemble back by 2:15 p.m. for the next quiz. And please contact Ashley Bretley for the preliminary